Do you eat tuna, fish and chips, or shark fin soup? Any idea how much material it took to produce your 100-gram tin of tuna? Well, because marine food webs and ours on land are very different, you might be surprised. In the ocean there are more trophic levels, more steps in the food chain than ours on land. It's because at the base of the marine food chain, the phytoplankton are really tiny. Phytoplankton is the foundation of the marine food web, just like grass, leaves, nuts and fruits are for us on land. But because phytoplankton are so small, the herbivores that feed on them also need to be small. These zooplankton, the tiny herbivores like larval krill that graze on the phytoplankton, can be smaller than a pinhead. These tiny herbivores are eaten by tiny carnivores, and bigger carnivores eat these tiny carnivores, and in turn they are eaten by bigger carnivores. It's common for ocean food webs to have 5 or even 6 trophic steps. But as one animal eats the next, only 10% of the energy from the material they fed on gets transferred up into the next trophic level. The rest, 90% of the biomass, is used by the animal to do all the stuff it needs to do, to grow, move, repair, or it's eliminated, it's pooped out. But here on land it's different. We have short food chains. You think about it. Plant material like grass and leaves are eaten by herbivores, and many of these are large animals. And then apex carnivores eat these herbivores. Sometimes you have other carnivores eating another carnivore, but many carnivores on land are first consumers, which means they sit only at that 3rd trophic level. So on land, food chains are typically short, and long food chains exist, but they're rare. However, in the sea, marine food webs are extremely long, in fact the longest on Earth. But it's not completely that simple, as the largest animals in the sea feed at low trophic levels. Huge filter-feeding animals like baleen whales strain tiny zooplankton from the water. We don't see the equivalent on land. Imagine a carnivorous mammal the size of an elephant racing around catching flocks of dragonflies. So how can this work in the sea? Under the right conditions, phytoplankton multiplies at amazing speeds, and immense blooms spread across our oceans. In some regions, a teaspoon of seawater can house millions of living creatures, those tiny zooplankton. So for animals that have special modifications to filter feed, like the baleen of whales, which is a hair-like material that hangs from the roof of the whale's mouth, they can quickly trap enormous amounts of these tiny zooplankton from the water. And because they're eating near the very base of the food chain, there are few trophic level hops, so little energy is lost. And this is why they can reach enormous sizes. So what about us now that we've entered the marine ecosystem? Well, we tend to like fish such as tuna or fish and chips, which, if it's flake, is actually shark. Or you might eat shark fin soup. These fish sit at the top of the food chain. So eating shark fin soup or tuna is like us eating something that eats lions, if there was such a creature. So if we go back all the 5 or 6 trophic levels to the base of the food web, to produce this 100-gram tin of tuna, we need 1 tonne of phytoplankton. And although our oceans are vast and it seems that fish populations are limitless, this is not the case. We need to be careful in managing our fisheries. And so far, we don't have a good record.